Okay, so in this question we have ideal gas contained in two flasks. So we can apply the ideal gas equation. For this flask, let's say the amount of gas in flask X is N1 and the amount of gas in flask Y is N2. So for flask X, we can write this equation. Px Vx will be equals to N1 RT. We can do the same for flask Y. So Py Vy will be equals to N2 RT. So now this tab is opened and therefore it now becomes one big flask. So again we can apply the ideal gas equation. So as one gas, right? As one gas, we can write P, because the pressure in these two flasks is the same. This because they are already connected, so it's not possible for the pressure here to be say higher than here, because if the pressure here is higher, that means the gas will flow from here to here. If the pressure is higher here compared to here, then the gas will be going from here to here. So if everything is settled, I mean that when there's no more net movement of gases from one flask to the other, it must mean that the two flasks are at the same pressure. So the pressure of this combined gas is P, and the volume of this combined gas is of course V, because the question says that V is the total volume of these two flasks. The amount of gas in here would be N1 plus N2. Let's put a prime, because to represent the new amount of gases in two flasks. So R would still be R and T would still be T. Of course, we know that the total amount of gases shouldn't change. Some gas may go from one to the other, but the total amount should be the same. So from this side, from the left side, we can write N1 to be Px Vx over RT, whereas N2 we can write it as Py Vy over RT as well. And for the right hand side of the equation, from this equation we can write it as PV over RT. So we can happily cancel away the RTs from both sides, and we arrive at this expression here. Px Vx plus Py Vy is P times V. Easy.